In this video, I want to talk about an important formula called the difference quotient. And so here we have the difference quotient written. You can think of this as a formula, but I want to talk about its significance. So I'm going to draw an x and y axis. Okay, and then some function, we'll call this f of x. We want to talk about what each of the pieces of the difference quotient actually signify. So the first thing I want to talk about is what is the importance of this letter h. So if I was to take some point around x and go a short distance away from x, let's call that distance h, then that distance to this new spot right here is going to be x plus h. So if I go up to the function value at that particular point, that is going to be the value f of x plus h. So what we see here, and then over here, the original x value, that's going to be f of x. So if I was to draw a line going directly through both of those points, this is going to be a secant line passing through those 2 points. The question is, what is the slope of those 2 points? Well, remember, it's the difference in the y's, so the change in the y's divided by the change in the x's. Well, the y values here, if I was to write these, let's make this 2 different points. So let's take these 2 values, and if we make those into points, that's going to be x plus h, and then f of x plus h, and then this point over here is going to be 8. This point over here is going to be x and f of x. So the difference in the y's for this is going to be f of x plus h minus f of x over, and then take the difference in the x's, so that's going to be x plus h minus x. So if I simplify that, that gives me f of x plus h minus f of x all over, and h is the only thing that survives in the bottom. So again, this little h is a distance from some x value then that means the difference quotient is simply the slope between any 2 points on any given function. So let's look at an example of how we actually calculate the difference quotient. So let's say that I have some linear function, f of x equals 3x plus 2. I want to find the difference quotient. Okay, so the difference quotient is f of x plus h minus f of x all over h. So I'm going to have to highlight some stuff. First of all is the inside here. What that's saying is everywhere I see an x in my original problem, I need to replace it with x plus h. So I'm going to write my original function 3 parentheses plus 2, and what I'm going to replace in there is that x plus h. Then the next piece, minus f of x, says we'll subtract the original function from what you had just had, so that's going to be minus 3x plus 2. Now I do want to take a moment and make a note. And I want to point out that parentheses are very important here. Because if you mess up the parentheses, you're going to end up messing up the signs, which is going to give you the wrong answer in the end. So we have the first piece, we have the f of x plus h, right there. And we have the minus f of x. So this should be all over h. So let's do some simplification. First we'll distribute here. So that's going to give us 3x plus 3h plus 2. And then I'm going to distribute this negative to give me minus 3x minus 2 all over h. Okay, so I see some stuff cancels. So the first thing is right there, the 3x and the negative 3x will cancel. But also that 2 and the minus 2 cancel. So the only thing that survives on the top is 3h, and the only thing that survives on the bottom is h. So that simplifies to just 3. Now, given that the fact that the difference quotient is nothing more than slope, this should be rather obvious because the slope of that linear function is 3. So let's do one more example where it is not necessarily linear. So here we have the function 5x minus x squared. So we want to find the difference quotient. I'll write down the formula. And again, highlight the point that everywhere we see an x in our original function, we're going to replace that with x plus h. So if I write that down, I'm going to have 5, and then I see an x, so I'm going to leave an open parentheses because I'm going to replace that with x plus h, minus open parentheses, and that's in there is going to go x plus h as well. And then again, we have this minus the whole function. Remember, parentheses are very important, so I'm subtracting off the whole function, 5x minus x squared. And this needs to be all over h. So now I'm going to do some simplification. First thing I'm going to do is distribute here. So it's going to give me 5x plus 5h minus, I need to FOIL out this x plus h squared piece. So if I take that, come over here to the side, x plus h, that gives me x squared plus 2xh plus h squared. So I come back into my difference quotient and say, okay, that's going to be minus x squared plus 2xh plus h squared. Again, notice I use parentheses. That's very important because there's a minus sign in front of it. And then I can distribute this negative here, so minus 5x plus x squared. And I don't want to forget that this is all over h. So now our job is to just keep simplifying. So we get 5x plus 5h minus x squared minus 2xh minus h squared minus 5x plus x squared all over h. And I'm going to look for stuff that cancels. So let's see, 5x cancels, x squared cancels, and that looks like it's all that's going to cancel for now. So let's see what we've got. We've got 5h minus 2xh minus h squared all over h. Now what I notice here is that everything has an h in it, which means that I can factor an h out of the top. So I'm going to say h quantity 5 minus 2x minus h quantity, or all over, sorry, h. And that allows me to cancel out those h's. So my final difference quotient is 5 minus 2x minus h. Now you may wonder, well, why was the other one a single value? This one looks like it's an equation. And that's because when we have this function, when we have x squared, let me rewrite this as x times 5 minus x, then this function crosses through 0 and it crosses through 5. We're going to have something looking, not exactly, but kind of like this. Alright, and you'll see that the slope of this between any 2 points, say for example here and here, is going to be different than the slope of something over here. So it depends on where we're at and how far out we go, which is what this equation is saying. So for example right here, this is saying the slope depends on the x value and how far the next point is from x. So if we were to be given some x value and the distance to the next point, then we could find the slope between those 2 points using this. This is a very powerful tool for calculus, which is why we are learning about it, and we will see more in depth about this either in a later course or if you're taking calculus once you start doing derivatives.